Dear students, today's topic is potentiometer. Now, before starting this topic, let's discuss what we have studied earlier in current electricity. EMF. What is EMF? EMF is the maximum potential difference between two terminals of a source when it is open circuit. Open circuit means when no current is drawn from the source. Then the potential difference across its two terminals is known as EMF. That is why it is maximum. Second is potential difference. Potential difference may exist between any 2 points of a closed circuit. Means it is the potential difference across two terminals when the current is drawn from the source. Third you have studied is about voltmeter. What is voltmeter? A device used to measure potential difference across two ends. And ideal voltmeter. See, when we are talking about voltmeter, potential difference across two ends means that it should offer high resistance. That is, no current should pass or negligible current should pass through voltmeter. But when we talk about ideal voltmeter, what is required? That it should offer infinite resistance so that no current will pass through it and you will be able to find out EMF of the cell or source. But this ideal voltmeter cannot be attained practically. So we conclude that with the help of potential voltmeter we cannot find out the potential EMF of the source. So this is the limitation of voltmeter, that we cannot have an ideal voltmeter to determine EMF of the source. That is why it is required to study another device known as potentiometer. So now let's talk about potentiometer. In this topic of potentiometer, we will discuss about what is potentiometer, its construction, what is the working principle on which it is based on, about potential gradient and its applications, two applications, one to compare EMF of two cells, another to determine internal resistance of the cell, and we will talk about its sensitivity. Now, what is potentiometer? Potentiometer is nothing but a device. What type of device? Which do not draw any current from the circuit and measures the potential difference. That is, without drawing any current from the circuit, what it do? It find out the potential difference. And a device which measures an unknown EMF or potential difference accurately. Such type of device is known as potentiometer. Now its construction. Its construction, you can see this in the picture and you must have seen this apparatus lying in the physics lab whenever you have visited the lab. What is there? What about its construction? That there is a wooden board, and on this wooden board there are many parallel stretched wires. You can see that these are parallel stretched wire, but they are not connected in parallel. They are connected in series through these copper strips. So through this copper strip, all the wires are connected in series. They go like this. So this is the continuity of the wire, right? So the meter bridge wire are joined in series by using a thick copper strip. Now the question is, why we are using copper strip? Same thing was there in Wheatstone bridge, that we are using copper strip. So why we are using copper strip? Because it offers negligible resistance. Then there is a graduated meter scale through which we can measure the length at null point or balancing point. Another important thing is the material of the wire. The wire should have high resistivity and low temperature coefficient. High resistivity and low temperature coefficient. Low temperature coefficient means its resistivity should not change with a very small amount with the rise or change in temperature, rise or fall in the temperature. So if it has got low temperature coefficient, then we say that its resistivity is almost constant, invariable, is not varying with temperature. So these things are important. That is, number one, that it should have high resistivity. Number two, it should have low temperature coefficient. Then its working principle. The working principle, before starting this working principle, three things we have to remember. Number one, that its working principle its working principle for the working of potentiometer, the wire should have uniform cross sectional area. Wire should have uniform cross sectional area and uniform composition. Uniform cross sectional area means the area of the cross sectional area of the wire should be same throughout the potentiometer. It should have uniform composition means it should have uniform resistivity throughout the circuit, and constant current should flow through it. So three things are required. If these three things satisfies, then the potential difference across any length of a wire is directly proportional to the length of the wire. Directly proportional to the length of the wire means what we can say, that the potential difference across any portion of the wire is directly proportional to the length of that wire, provided that the wire should have uniform cross sectional area and uniform composition, and constant current should flow through it. I hope the concept of working principle is clear to you. Now, this we can prove mathematically by using Ohm's law. We know that according to Ohm's law, V is equal to IR, and you know that R, the resistance, is equal to rho L by A, where rho is the resistivity, L the length, and A the cross sectional area. If the constant current flows, means if I is constant, a potentiometer wire of uniform cross sectional area means A is constant, and uniform composition of the material means rho is constant. In that case, I, rho, and A, these three terms, they are constant. So we say that if we replace this constant I rho by A by another variable k, then we get V is equal to k times L. So V will become k times L, or we can say that V is proportional to L. This is how we can mathematically verify this principle of potentiometer. I is constant, rho is constant, A is constant. In that case, V is proportional to L. Practically also we can verify it by having this type of setup. You can see that in this setup there is a positive this is a positive terminal which is connected to the, or zero terminal also, which is connected to the positive terminal of the battery. There is a voltmeter, there is a jockey, and you can see that this is a potentiometer wire of 400 centimeter length, means 4 meter length wire. This is ammeter to measure current, and this is the rheostat through which we can set constant current drawn from the battery and constant current flowing through the potentiometer wire. Now if we go on changing the length of the wire, suppose हमने जॉकी को रखा 50 पॉइंट पे, that is 50 centimeter पे, somewhat here we are going like this. तो सपोज हमने उसको 50 पे रखा, या 100 भी कह सकते हैं, हमने 100 पे रखा, देन हम उसको लेके आते हैं 200 पे, देन हम इसको ला रहे हैं 300 पे, 400 पे. In that case what we will realize that the potentiometer reading, voltmeter reading will also change, that is the potential difference will also change in proportion to the length of the wire. So this is a practical setup to verify this V is equal to KL or V is proportional to L. Now there is another term known as potential gradient. Gradient word is not new for you. In 11th standard you have studied about gradient, that anything which is changing with length. So here potential gradient means potential drop, that is the change in potential with respect to length. So we can define potential gradient as potential drop per unit length of the potentiometer wire. As now, as you know, V is equal to KL, so we can have K is equal to V by L. This K is called potential gradient. As in terms of SI unit, the unit of potential gradient is volt per meter. But since meter is a very big, we measure unit of length to measure the potential or EMF of the cell. So in practice we are using length in terms of centimeter. So practical unit of potential gradient is volt per centimeter. If we plot a graph between V and L, then we get a straight line. So this straight line indicates that V is proportional to L. The slope of this graph will give the potential gradient. More the slope, more will be the potential gradient. Now let's talk about the application of potentiometer. The first application is comparison of EMF of two cells using potentiometer. So this is a potentiometer. Again we have taken a potentiometer of 400 centimeter length. सी ये जो हम चार वायर्स दिखा रहे हैं इसमें, इसकी जगह हम सिंगल वायर भी दिखा सकते हैं. इसकी ज़रूरी नहीं है कि हम 10 वायर या 4 वायर का पूरा इस तरह से एक लूप बनाएं. हम इसको सिंपली एक सिंगल वायर का भी बना सकते हैं टू ड्रॉ सर्किट डायग्राम. ठीक है, जस्ट टू save our time. Now here A terminal is positive, connected to the positive terminal of the battery, and B is connected to the negative terminal of battery. This is called the basic circuit, and this is what we call is the auxiliary battery. Same thing is there, that constant current is drawn from the battery with the help of by setting the rheostat. With this current, how much is the current can be measured by the ammeter. So when we insert key, the main key, the current has been drawn from the auxiliary battery. Now these through this positive terminal A, the cells whose EMF is to be compared, their positive terminals are to be connected. The negative terminals of the cells, they are connected by a two-way key. Two-way key means if we are inserting this key, E1 will be in the circuit, and if we insert this, E1 will be open and E2 will be in the circuit. Then you can see there is a resistance box. This resistance box must have high resistance. This box, the use of this resistance box is simply to save our galvanometer, because when we put the jockey at A end or at B end, the deflection on the galvanometer should be extremely left or extremely right. But to save the full scale, to avoid full scale deflection, what we do is connect a high resistance in series with the galvanometer. Now if we slide the jockey, suppose E1 is in the circuit, and E1 is in the circuit, say this key is closed, and we slide the jockey right from point A onwards. Then suppose we find that on sliding the jockey at this point J1, the galvanometer is giving null deflection. The pointer of the galvanometer is coming at null point or the 0 point. At that moment we will stop and we will measure this length A J1 with the help of scale. Then we will repeat this experiment by inserting this key and making E1 open circuit. Now E2 will be in the circuit, and again we will do the same job, and supposing that the null point which we are getting is at J2. So A J2 will get this length we will measure, and according to the principle of potentiometer, see, the constant current is flowing through the wire. Your wire is of uniform cross sectional area and uniform composition, so the EMF of the cell will be directly proportional to first of all, EMF of the cell will be equal to the potential difference across A and J1 in first case. And this A into J1, AJ1 potential is nothing but I rho L1 by A, और हम कह सकते हैं इसको K times L1. Similarly, EMF E2 can be written as potential difference across A and J2, and this is nothing but KL2. This is in accordance with the principle of potentiometer, and also we can have this on the basis of Kirchhoff's loop rule. Second law. Say this is E1, this is offering since here the current is 0, so we can use Kirchhoff's law for this mini circuit, and we get this equation that E1 is equal to K times L1. Same job we will do for E2, and we'll say that E1 and E2 are the EMFs of the cell. E2 is equal to K times L2. Now the value of K is not required because we have to compare the EMF of two cells. So we can say that the EMF, the ratio of their EMF, that is E1 by E2, is equal to L1 by L2. So simply measuring L1 and L2, we can compare by comparing the lengths, we can compare the EMF of two cells. This application is very important in theory as well as in practical, because you have to do the practical to compare the EMF of two cells using potentiometer. In practicals, we are using two cells, as one as a Lagrange cell and another maybe any other cell, maybe Daniell cell. So this is how we can do comparison of EMF of two cells. Now, its second application is to determine internal resistance of the primary cell. If you look at the circuit diagram, now what is the change on the circuit diagram from the previous one? यहाँ पे हमने 4 वायर्स लिए थे. जैसे मैंने आपको भी बताया था कि हम ये 4 इतना लंबा वायर का लूप नहीं लेने के बजाय हम इसको सिंगल वायर भी ले सकते हैं. सो नाउ दिस इज़ व्हाट वी हैव टेकन इज़ अ सिंगल वायर. This is only for making circuit diagram in theory. just to save our time. Now A is connected to the positive battery जैसे previous case में भी था, and B terminal is connected to the negative through rheostat and key. So this is the basic circuit which do not change whatever application we are doing of potentiometer. Now since A is connected to the positive of the battery, this is also known as 0 point. Why? Because all the measurements we will do from A, not from B. So this thing you have to remember, that the 0 point means the point from where we are measuring the length, and this should be the positive terminal of the this should be connected to the positive terminal of battery. Now what is the difference in this circuit and the previous one? We have taken two cells whose EMF we have to compare. Now here we have to find out the internal resistance of a single cell, single primary cell. So what we will do, we will put a single primary cell. It may be a Lagrange cell, maybe a Daniell cell. This is a primary cell, and in parallel there is a the resistance box, maybe of high resistance. Resistance box means which is having variable resistance. It has many keys, and whichever key we are picking up, that much resistance will be there in the circuit. Now when this K1 key is open, अगर ये K1 key open है और हम इसको गैल्वेनोमीटर से कनेक्ट किया है, गैल्वेनोमीटर इज कनेक्टेड टू जॉकी, जब हम इसको स्लाइड कराएंगे, ओपन सर्किट का मतलब है सपोज वी आर गेटिंग नल पॉइंट एट J1. So AJ1 will give this length will be proportional to, or EMF will be proportional to this length AJ1. So we can say that E is equal to potential between A and point J1. So this is nothing but EMF of the cell, which is equal to K times L1. Why EMF of the cell? Because this circuit initially is open and no current is drawn from this cell. So we can say that according to the principle of potentiometer, the EMF of the cell will be directly proportional to this length AJ1. नाउ इफ़ वी क्लोज द सर्किट, जब हम सर्किट को क्लोज करेंगे, यानी हमने यहाँ पे की इंसर्ट कर दी और यहाँ से कुछ रेजिस्टेंस निकाल दिया बॉक्स में से, तो क्या होगा, इस मिनी सर्किट में से सेल में से सर्किट फ्लो करेगा, ड्रॉ होएगा, और ये मिनी सर्किट में एक छोटा सर्किट बन गया जिसमें करंट फ्लो करेगा. इसका मतलब जब करंट इस सोर्स में से फ्लो करना शुरू करेगा तो क्या होगा, यहाँ पे पोटेंशियल ड्रॉप आएगा. पोटेंशियल ड्रॉप अगर आएगा तो अगर हम वापस से इसको स्लाइड कराएंगे तो वी विल फाइंड दैट द नल पॉइंट विल चेंज फ्रॉम J1 to J2, and this null point will give us not EMF but the potential difference, and this is equal to the potential difference between A and J2. Now remember one thing, that AJ1 will always be greater than AJ2 because EMF is always greater than potential difference. So finally E by V will be equal to L1 by L2. So now if we recall the previous topics of internal resistance of the cell, we can find out by replacing the value of E by V. According to in this circuit, if internal resistance of this cell is small r and capital R is the resistance taken out from the resistance box, then according to formula according to Ohm's law, E is equal to I R plus R. And secondly, we know that V is equal to IR. On finding out the ratio, we get E by V is equal to R plus R upon R, or this E by V is L1 by L2. So if you solve this left hand side, you will get 1 plus R by R, small r by capital R, is equal to L1 by L2, or a small r by capital R is equal to L1 minus L2 upon L2. Finally, the internal resistance of the cell will become capital R times L1 minus L2 divided by L2. This is how we find out the internal resistance of the primary cell. Now, again I am repeating that L1 should be greater than L2. Uh, uh, this is how we find out the internal resistance of the primary cell. Now, another important topic is sensitivity of potentiometer. A potentiometer is sensitive. कोई भी डिवाइस सेंसिटिव, अगर हम उसकी सेंसिटिविटी को डिफाइन करेंगे तो क्या होगा, हम उसको देखेंगे व्हाट इज़ दैट डिवाइस. डिवाइस इज़ टू मेजर ईएमएफ. तो इफ़ इट इज़ सेड टू बी सेंसिटिव if it is capable to measure very small potential difference, and it shows a significant change in the balancing length for a small change in the potential being measured. Means it should be able to, if it is able to find out the small potential difference, or its if the potential is changing, then if the balancing length is changing by a significant value, then we say it is our potentiometer is sensitive. The sensitivity of potentiometer depends upon potential gradient along its wire. So this thing is very important. Sensitivity of the potentiometer depends upon potential gradient along its wire. The sensitivity of potentiometer can be measured by reducing potential gradient. So if you reduce the potential gradient, it will become more sensitive. As we know that potential gradient is equal to V by L. So if you increase length of the wire, say we have seen single length wire of 1 meter, of 4 meter, of 10 meter. So out of these three, the potentiometer of having wire of 10 meter will be more sensitive as compared to 4 meter or 1 meter wire. So by increasing the length of the wire of the potentiometer, we can increase the sensitivity of the device, that is potentiometer. Secondly, the potential gradient can be reduced by decreasing current, because another formula for potential gradient is K is equal to I rho by A. Since A and rho are not changing, they are constant. So this rho and A are not changing. What is on which it depends? If I decreases, if we decrease the current, though the constant current will flow, but if we decrease the value of current in the circuit, then it will become sensitive. So finally we can say that the sensitivity of potentiometer can be increased by increasing the length of the wire, potentiometer wire, and secondly by reducing the current in the circuit with the help of rheostat. Now, the things which we have to remember, first is the principle of potentiometer, that it requires that the wire should have uniform cross section, uniform composition, and constant current should flow through it. Then only its principle will be applicable. The working of potentiometer is based on null deflection method. So resistance of the wire becomes infinite. Thus potentiometer can be regarded as ideal volt, because if the wire is offering infinite resistance, we can call it an ideal voltmeter. Then the balance point will not be obtained on the potentiometer wire if the fall of potential along the potentiometer wire is less than the EMF of the cell to be measured. This is very important. Practically, when we do the experiment, sometimes we get same side deflection at both the ends A and B. So this may be because of the fall of potential along the potentiometer wire is less than the EMF of the cell to be measured, or this may be possible when the EMF of auxiliary battery is less than the EMF of the cell. So what is required, that the EMF of auxiliary battery should be greater than the EMF of the cell to be measured. If it will be less, then again you will not get balancing point. The positive terminal of auxiliary battery and the cells must be connected to the zero end of the potentiometer. Both positive of the battery and the positive of the cell should be connected to a single terminal, and that terminal should be zero end of the potentiometer. So these things are to be remembered. They are helpful in this application based questions and in MCQ objective type questions. Now, some important formula related to this topic, that E1 upon E2, that is EMF of two cells, the ratio of EMF of two cells is equal to the ratio of the length of their length of this portion, two portion. Then internal resistance of the cell R is equal to capital R sorry, L1 minus L2 upon L2. Third, potential gradient K is equal to V by L. Fourth, unknown EMF E is equal to K into L. I hope आपको ये टॉपिक समझ में आ गया होगा. Now prepare notes and learn the formulae and important points. Thank you.